Hello everyone, today is lecture 7 of information theory and coding. Here we will discuss about source coding as a prefix coding as well as remaining part of the mutual information as in the last class. Okay. As in the last class of mutual information, we have seen through Venn diagram, that is IXY given as HX minus Hx upon y or Hy minus Hy by x, and we have derived the expression for the Ixy as Ixy summation over j n minus 1 summation over k m minus 1 joint probability p x j upon y k into log of base 2. In case of Ixy, it was p x j upon y k divided by p x j divided by p x j. Okay. While we have also derived another expression using the formula of joint entropy, that is the p x j y k is equivalent to p y k upon x j into p x j equivalent to p x j upon y k into p y k. Equating these two equations, we can say then p x j upon y k equivalent to p x j upon y k, here we can p x j upon y k into p x j, okay, equivalent to p y k upon x j into p x j here and p y k here. P y k here. So that p x j upon y k divided by p x j equivalent to p y k upon x j divided by p y k. So that p x j upon y k upon p x j equivalent to p y k upon x j divided by p y k. Then this equation becomes j is equal to 0 to n minus 1, k is equal to 0 to m minus 1, joint probabilities p x j y k log of base 2, this becomes p y k upon x j divided by p y k. Okay. These two expressions for the Ixy that we have derived in the last class also. Similarly, here in this equation, if you multiply p x j both side, suppose in the second equation multiply p x j both side, numerator and denominator, then this becomes double summation p x j y k log of base 2. When you multiply with the p x j, then p y k upon x j into p x j, that is the joint probability. Then this become p x j comma y k divided by if you have multiplied p x j both side, then divided by p x j into p y k in denominator. Okay. This is the third expression for Ixy. not going completely. Okay. Now, this third expression, okay, of Ixy, that is nothing but the equation of the relative entropy, that summation probability log of base 2 probability upon relative probability P upon Q, and here P. Then as we know that probabilities of the relative entropy, that is D of P over Q, always positive. Okay. So, Ixy that is the mutual information, it is always positive. D P over Q always positive, that we have derived in the earlier classes. Then it is becomes one property of Ixy, that is the mutual information. Another property, that is Ixy equivalent to I y by x, sorry, I y comma x. This is nothing but the I y comma x. Okay. That also can be derived using this equation, because Ixy, similarly if you write the equation for the I y by x, then it remains same, yk comma xj, it remains same, yk comma xj, it remains same. Then you can derive this equation. And third property, already using this equation, we have seen, that is the Ixy equivalent to hx plus hy minus hxy. Okay. Then this is the properties of the mutual information. Now come to the binary symmetric channel. Okay. See, binary symmetric channel can be given as two input or two source symbols at the input side, two source symbol at the output side. This is x 0 equals to 0, this is x 1 equals to 1. If the binary symbols, here y naught equals to 0 and y 1 equals to 1, here also binary symbols. Okay. We can draw its symmetric diagram, that is when input is x naught equals to 0 and output is y 1 equals to 1, then its probability of error is p. So that probability of correction is 1 minus p, that is 0 input and 0 output. Okay. Similarly, when 1 input and 0 output, then probability of error suppose p, then probability of correction is 1 minus p, that is the one input and 1 output. Okay. This is the symmetric diagram of the binary symmetric channel. Okay. Now channel capacity and the mutual information, then channel capacity is nothing but the maximum of mutual information. Mutual information, that is if there is a channel, here source x is input, okay, output is y, okay, with some symbols n symbols, and at the input y m symbols at the output, and if you see the mutual of these input and output, then those symbols which are passing correctly through the channel, okay, that is the mutual information. If you maximize the mutual information, you can get the channel capacity, okay, that is the maximum common symbol passing through the channel at a time. Okay. Now function of entropy of BMS and channel capacity. Okay. Then firstly we have to find the channel capacity of the binary symmetric channel. Okay. See, maximum of the mutual information, then we have to find the mutual information maximization. We can see C is equal to maximum of I x y, this maximization over input probabilities P x j, because that is independent. Okay. That is the input probabilities. Okay. Now, for binary symmetric channel we have to find I x y and maximize this to get the its channel capacity. Okay. Then as per the equation of I x y, suppose we have taken the equation summation over j summation over k joint probability P x j y k log of base 2 P y k upon x j divided by P y k. Okay. Suppose we are taking this formula or equation of the mutual information to get its capacity C. Okay. Here in the case of binary symmetric channel, this is j is equal to 0 to 1, k is equal to 0 to 1, P x j y k, okay, and log of base 2 this one. Then we have to find joint probabilities for this. Conditional probability is already given. Okay. Input probabilities, then to maximize this one, then as in case of entropy, that was maximum when input probabilities are equiprobable. Then we take input probabilities at P x naught equals to P x 1 equals to half, that is the equiprobable case when entropy was maximum. Here again we can get the this one as a maximum for P x naught is equal to P x 1 is equal to half. Here the given binary symmetric channel, here we can see that the probability of y naught when input is x naught, probability of y naught when input is x naught given, that is the 0, this is nothing but the 1 minus p, and this is also equivalent to the probability of y 1 when x 1 given. Similarly, probability of y naught when input is x 1, probability of y naught when input is x 1, this is nothing but the p, and that is also equivalent to probability of y 1 when input x naught, this is equivalent. Okay. Then these conditional probabilities are given, input probabilities are given, we have to find joint probabilities, okay, as well as output probabilities to get I x y. Okay. Then joint probabilities P x naught y naught, suppose that can be given as P y naught upon x naught into P x naught. P y naught upon x naught already we have mentioned, that is 1 minus P probability of correction into P x naught, that is the half. Okay. Similarly, P x 1 y 1, that is the probability P y 1 upon x 1 conditional probability into P x 1, and here also probability of correction 1 minus P into P x 1, that is the half. Okay. Now, joint probability of x naught y 1, that is the probability y 1 upon x naught into P x naught, that is nothing but the P into half, and probability of x 1 with y naught, that is the probability y 0 upon x 1 into P x 1, then error probability P into half. Okay. These are the joint probabilities which will be used to find the mutual information. Okay. Now, output probabilities, how we will find the output probabilities P y k, then P y k is nothing but the summation over j 0 to n minus 1 joint probability p x j y k. Okay. Here this is nothing but the j is varying, suppose p y naught, then this is nothing but the p x naught y naught plus p x 1 y naught. Similarly, p y 1 p y 1 is equal to summation, then this is p x naught y 1 plus p x 1 y 1. Okay. So that first case p y naught equivalent to p x naught y naught, p x naught y naught, that is the half of 1 minus p, half of 1 minus p plus p x 1 y naught, p x 1 y naught, that is the half of p, you will get 1 by 2 only. Similarly, p y 1, that is also half. Then output probabilities calculated, joint probabilities calculated. Now we can put these values into the equation of the mutual information. Mutual information, that is the I x y double summation over j over k, okay, p x j y k into log of base 2 p y k upon x j divided by p y k. N is equal to 2, m is equal to 2, and we can write it as summation j is equal to 0 to 1, k is equal to 0 to 1, p x j y k log of base 2 p y k upon x j divided by p y k. So that this becomes, for j is equal to 0, k is equal to 0, p x naught y naught log of base 2 p y naught upon x naught divided by p y naught, plus second case j is equal to 0, y is equal to 1, p x 0 y 1 into log of base 2 p y 1 upon x naught divided by p y 1. Okay. Similarly, third term, when p x, this is x is x 1 y naught log of base 2 p y naught upon x 1 divided by p y naught, plus p x 1 y 1 log of base 2 p y 1 upon x 1 divided by p y 1. Okay. Putting the values here, we can find I x y equivalent to p x naught y naught, and that was we have already calculated this one, okay, to get the channel capacity. If we put the values, then directly we can find this is nothing but the 1 plus p log p plus 1 minus p log of 1 minus p base 2. This we will get if we putting the values as calculated in the last slide, and I x y can be given this one. This I x y is nothing but can be interpreted as 1 minus H p. Here H p is nothing but the minus of p log of t base 2 minus 1 minus p log of base 2 1 minus p. Okay. This equation of entropy we have seen while calculating the entropy of binary memoryless source. If you remember, okay, then that equation can be used here. Okay. Then h function of p, then I x y can be given in terms of this one. Okay. Now, this can be plotted, this equation we can plot it. Okay. Then its plot is like this one. It is H p, if we plot H p, it was like this one. We have already discussed, that is its value is 1, that is maximum at p is equal to 0.5. Okay. This is the H p, while 1 minus H p you will get its plot like this one. Okay. This is the capacity C, because its maximum value we have calculated of the I x y, then C is equal to capacity of the binary symmetric channel, that is the 1 minus H p, and this is the plot. Then here as per capacity plot, its value is, capacity is 0 when probability is half, that is uncertainty is maximum. Okay. The probability is half, uncertainty maximum, then channel capacity minimum zero information passing through the channel. Okay. But when probability is 0, uncertainty is 0, okay, then capacity is maximum, that is the 1, that is the probability 0, p is 0, then correction probability, that is the 1 minus p, that is the 1, that is always 1, then its capacity is maximum. Similarly, when probability is 1, okay, again 1 minus p is 0, that is certain, then capacity is highest, that is the 1. Okay. Source coding and other things we will discuss in the next class. Okay. Thank you.